everybody. This video is about measuring arcs and central angles in circles. So in this example, we're asked to find the measure of angle EFD. Well, this isn't new, really. This is just an angle. And in order to do most of these types of problems, you really only need a couple of facts. One fact is that the angles in a circle add up to 360 degrees. The angles in a half circle add up to 180 degrees. And if you remember from quite some time ago, vertical angles are congruent to one another. So with these three facts, we'll be able to tackle most problems. Now in this particular question, if you'll notice, we have a 125 degree angle, and we have this central angle that together form half of a circle. Well, since half of a circle measures 180 degrees, that means this angle, which I can call whatever I want. Actually, I don't even need a variable name. I'm not going to introduce algebra if it's not necessary. But the central angle with this 125 degree angle add up to be 180 degrees. Well, that means 180 minus 125 is going to be the measure of angle EFD. So this is just a subtraction problem. This is not an algebra problem. So 180 minus 125 is 55 degrees. So the measure of angle EFD is 55 degrees. Now, I'm going to go ahead and erase all of these properties. So just remember, circle adds up to 360, half circle adds up to 180, and vertical angles are congruent. I think we'll use all of these properties in our various problems. So next, we have another circle, but we have some new notation here. So we have M, which means the measure, and this is the measure of arc KHJ. Well, when you have these three letters together, it means you go from K to H, that's the letter in the middle, all the way around until you get to J. Now, just be aware, if a problem said, for example, KJ with an arc over it, that would mean directly from K to J in the shortest distance possible. KJ is what's called a minor arc, whereas KHJ, that's called a major arc. Now, the question remains, what does it mean to measure an arc from K to H to J? Well, you might think, if you've never seen a problem like this before, that we're talking about the length of the arc. If you were able to straighten out the circle and measure it with a ruler, for example, that might mean the measure of the arc. Well, you can do that sort of thing, and we'll do it later, but that's not what we mean in this problem. Whenever you're talking about the measure of an arc in geometry, you're talking about the measure of the angle, the central angle that makes that arc. So we want the measure of this angle that I just drew in red. And here we'll need one of those properties that I mentioned before, namely the angle of an entire circle adds up to 360. And if I want this red angle, I just need to take off 34 degrees. So if I subtract 34, that's 326. So the measure of this major arc is 326 degrees. All right, let's do another few examples just to see the different properties and different ways that these questions can be stated. So here we want the measure of angle VQR. So this is another central angle. Let's see, we have this central angle, V to Q to R. So this is very much like the first example, where if you'll notice, we have half of a circle because this is a diameter. The instructions say that straight lines that look like a diameter are indeed diameters. So if that diameter is 180 degrees, and we subtract 79 degrees, well, that means that the angle that's left over is 101 degrees. So that means VQR must be 101. So that's kind of a repeat of the first problem. Let's move on then. So here we have another measure of an arc. This time though, it's a minor arc. There's only 2 letters there. So if there's only 2 letters, you go from T to S in the shortest distance possible. And remember, when you're measuring an arc, you're not measuring the length of it, rather you're measuring the central angle that makes that arc. So we're going to have to put a couple of properties together here, although I bet there's multiple ways to do this problem. Here's one way though. We have a diameter from T to Q, which means we have half of a circle, which makes 180 degrees. Well, from T to P, if that's 120, well, that means 60 degrees more make 180. And remember at the beginning of the video, I said there were 3 properties that would give you most of these problems. And one of those was that vertical angles are congruent. So arc PQ is vertical with arc TS, or rather the central angles are vertical, which means this angle is also 60 degrees, meaning the measure of the minor arc TS is 60 degrees. So that was an example where you do have to remember some things from the first semester in this class, that is, vertical angles are congruent. Okay, I think we have one more example to do, just to give you a few more things to play with. So this time we want, this is another minor arc, and this is the minor arc PT. So you go from P to T in the shortest distance possible. And notice we've switched a little bit in this problem. Now we have some algebra to do. So we have x's instead of just numbers, but you're still going to use the same properties. Either all the angles add up to 360, half of a circle, the angles add up to 180, vertical angles are congruent to each other, but this time we just put that in the context of algebra. So I think I'm just going to set this problem up and not solve it, because I think you probably see, well, we have half of a circle, which means these 2 angles add up to make 180. So we have 16x minus 6 plus 9x plus 11 equals 180. So in this case, solve this equation for x, either by hand or in the calculator, either one is fine, and then make sure you answer the question that's being asked. Once you solve for x, you're going to plug that in, you're going to plug x in to PT. So you'll plug that in for x, and you have 16 times x minus 6. That's going to be the measure of arc PT. Anyway, that's how you deal with central angles, major and minor arcs. Once again, angles in a circle add up to 180, angles in a half circle add up, angles in a circle add up to 360, angles in a half circle add up to 180, and vertical angles are congruent. That will get you basically everything that you need to do here. Anyway, hope this video helped.